Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an oblique cube which is having an edge 50 millimeter, and this cube is so placed on the horizontal plane that it will be resting on one of its corners on the horizontal plane, and the body diagonal of this cube, this is parallel to the horizontal plane and perpendicular to the vertical plane. So we are required to draw the orthographic projections of this oblique cube. Now let us first of all evaluate the orientation of this cube as it is going to rest onto the horizontal plane. So here we can see, if we choose this orientation of the cube onto the horizontal plane, now as this cube will be inclined with respect to the horizontal plane, it will be resting on one of its edges of its base onto the horizontal plane, whereas we have been provided with the information that this cube, it is resting on one of its corners on the horizontal plane. So this condition will not be satisfied into this orientation. So this is the incorrect orientation of the cube onto the horizontal plane. So while we locate the cube into this orientation, now we will find that as we incline this cube either this way or this way, it will be resting on one of its corners onto the horizontal plane. So this is the correct orientation of the cube onto the horizontal plane. Now we know that this cube, once it is tilted with respect to the horizontal plane, it should be resting on one of its corners. So here we can see either it will be resting on this corner or it will be resting on this corner onto the horizontal plane. Now how much is the angle of inclination of this cube with respect to horizontal plane? So this angle of inclination of this cube is not provided to us with respect to the horizontal plane. So what is the information available with us in this case? That the body diagonal happens to be parallel to the horizontal plane. So here we need to understand what do we mean by the body diagonal. So body diagonal means that it is a string or a diagonal which is going to join opposite corners of the base and the top face of the solid. So if we have this cube available over here, so this is the one of the corners of the cube on one side on the base, and if we join it with the opposite point C over here, which is the top face of this particular cube. So once we join points 1 and C over here, so this gives us the dimension or length of the body diagonal over here, right? So this way body diagonal is basically joining one corner of the base and the opposite corner of the top face over here. So this way, this is the longest diagonal which is available in the case of a cube. Now we have to orient or incline this cube in such a way that this body diagonal 1C, it should be parallel to the horizontal plane in the first instance. So that will provide us with the orientation or the inclination of this particular cube with respect to the horizontal plane. And in the second incidence, we have got the body diagonal, it is further rotated in such a way that it becomes perpendicular to the vertical plane. So in the second iteration, we are going to rotate this body diagonal with respect to the vertical plane in such a way that this body diagonal becomes perpendicular to the vertical plane in the second iteration. So this way we are required to obtain the orthographic projections of this oblique cube when initially the body diagonal happens to be parallel to the horizontal plane, and thereafter the body diagonal is further rotated to enable it to be perpendicular to the vertical plane. So let us proceed with the construction of the front view and the top view projections of this oblique cube over here. So to begin with, we are going to assume that the cube has to be constructed in such a way that the two edges of the cube, they will be at an angle of 45 degrees with respect to the vertical plane. Now first of all, we are going to draw the long XY reference line, and now the two faces of this particular cube, which will be represented as a square in the top view projections over here, so they will be inclined at an angle of 45 degrees with respect to the vertical plane, such that this cube, it should be resting on one of its corners onto the horizontal plane when initially the body diagonal is becoming parallel to the horizontal plane. That is, we are going to tilt this cube with respect to horizontal plane in such a way that this body diagonal should be becoming parallel to the horizontal plane in the first iteration. So let us start with the construction of the top view projection of this cube onto the horizontal plane, which will be obtained below the XY reference line. Now, once we draw this construction line at an angle of 45 degree, now the cube edge, we know this is equal to 50 millimeter. So now this cube has been constructed over here having an edge equal to 50 millimeter. And now let us label the four corners of the cube. So A, B, C, D, this is the top face of the cube, whereas 1, 2, 3, 4, it happens to be the base of the cube. So the base of the cube, we have labeled it on the interior side of this square construction, whereas A, B, C, D, we have marked as the top face of the cube. So having drawn the top view projections of this cube, now let us obtain the front view projections corresponding to this cube. Now we know that the height, it will also be equal to 50 millimeter. So now we have drawn projectors through A1, B2, D4 and C3, and using this height is equal to 50 millimeter. Now we have been able to obtain the front view projections over here. Now we can see that this vertical edge 2B, it is visible to the observer, and this vertical edge D4, it is away from the observer. So this is not visible to the observer, but this vertical edge D4 should have been drawn dotted over here. But since this vertical edge D4 projections will be overshadowed by the vertical projections of the edge B2, so that is why we are going to get a solid projection line corresponding to 2B as well as D4 over here, right? So this way the front view projections corresponding to the base will be 1 dash, 2 dash, 4 dash and 3 dash over here, and similarly the projections corresponding to the top face of this cube will be A dash, and then here we get B dash and D dash over here, and through this C we are going to get the top view projection of the top face over here as C dash. So now we have been able to obtain the top view projections of the cube as well as the front view projections of this cube. Now let us represent this body diagonal. So body diagonal is the one which is going to join leftmost corner of the base with rightmost corner of the top face of this particular cube. That is, we are going to join 1 with C. That is, in the front view, this body diagonal will be represented as a construction line which will be joining 1 dash and C dash over here. Now, in the first iteration, we have not been provided with the angle of inclination of this cube with respect to horizontal plane. Now we have been provided with this information that as we tilt or incline this cube with respect to the horizontal plane, it has to be inclined with respect to horizontal plane to the extent that this body diagonal, that is 1 dash C dash, now we can see this is inclined one. It is represented as an inclined construction line. We can see over here as well. 1C construction line, that is the corresponding to the one which is going to join the body diagonal. This will be inclined with respect to the horizontal plane. Now we have to tilt this cube in such a way that this body diagonal 1 dash C dash, it becomes parallel to the horizontal plane. So in the second iteration, this body diagonal, that is 1 dash and C1 dash, this should become parallel to the horizontal plane. Now in order to transfer this front view projections over here in such a way that this body diagonal becomes parallel to the horizontal plane, what we have to do? We have to draw another construction line from the point 3 dash onto this body diagonal, so that we should be able to work out the perpendicular distance between the point 3 dash and a point P dash, which we are going to obtain onto this body diagonal, so that we can ensure the rectilinear transfer or rotation of all of the distances of this front view projection into the rotated view projection when the body diagonal will become parallel to the XY reference line or the horizontal plane. So please check, from point 3 dash, now we have drawn a perpendicular projector onto the body diagonal, which is represented as 1 dash C dash in the front view projection. Now you can see this is the perpendicular projector that we have drawn. So wherever this perpendicular projector has intersected with this body diagonal 1 dash C dash, we have been able to locate this point P dash over here. Now why this point P dash has been located? Now we can see that if we join this body diagonal in the front view projection, we can check there are two similar triangles which we have been able to obtain. First triangle is 1 dash, A dash and C dash. Another similar triangle is 1 dash, 3 dash and C dash over here. So these are two similar triangles which we have obtained on either side of this body diagonal. Now what we are going to do over here, we are going to have this body diagonal parallel to the XY reference line or parallel to the horizontal plane at a height which will be equal to the height 3 dash P dash over here. Because now we know if we have marked this distance 3 dash P dash, now if we mark this distance over here 3 dash P dash, now this 3 dash P dash happens to be perpendicular to this body diagonal which happens to be 1 dash C dash over here. And we also know the distance, that is the rectilinear distance between P dash and C dash. We also happen to know the rectilinear distance between P dash and 1 dash over here. Now this cube will be tilted with respect to horizontal plane in such a way that it should be resting on horizontal plane on the point 3 1 dash over here. This is the first thing we need to remember, that is this point 3 will be represented as 3 1 dash over here. So this point 3 dash will be represented as 3 1 dash over here in the first instance, and then from point 3 1 dash we will be drawing a vertical projector line over here, and thereafter 1 dash C dash will be drawn perpendicular to this line which will be 3 1 dash and P1 dash, which we are going to draw over here. So please check, we have to ensure the inclination or rotation of this cube in such a way that this body diagonal, which will now become 1 1 dash C1 dash, it should become parallel to the horizontal plane. And how much should be the distance of this body diagonal from the horizontal plane? This distance will be equal to 3 dash P dash. So here you can check. This point has been marked as 3,1 dash. This point has been marked as P1 dash over here. So this distance we have marked over here. So this distance we have marked as same distance as we had obtained in the previous elevation projection view. So having obtained this point P dash, now we know that 1,1 dash and C1 dash will be perpendicular to this vertical distance over here. Now how much will be the distance between P dash and C1 dash? It is same distance as P dash and C dash over here. So onto this perpendicular projector line, we'll mark this distance. P dash C1 dash is equal to P dash C dash, and similarly P dash 1,1 dash distance will be equal to P dash 1 dash distance over here. So now we know that this body diagonal has now become parallel to the horizontal plane. So once we have located the points 1,1 dash and C1 dash over here, now again we know the rectilinear distance. We know the distance between C dash and A dash. We know the distance between 1 dash and A dash over here. So 1 dash A dash distance we know, C dash A dash distance we know. So once we know these two distances, we'll mark two arcs over here. One arc will be corresponding to the distance 1 dash A dash. So it is this distance. Another arc we are going to mark corresponding to the distance C dash A dash over here. So this is this distance C1 dash A1 dash. So this way, once we mark this distance and this distance, so the first part of the upper triangle we have been able to obtain. Similarly, we know the distance between C dash and 3 dash. We also know the distance between 1 dash and 3 dash. So please check, C1 dash and 3,1 dash distance will be the same distance. Similarly, 1,1 dash and 3,1 dash distance we also know. So another part of the similar triangle we'll be able to mark over here. So this is upper triangle which we have been able to obtain, which is symmetrical about this body diagonal, which is 1,1 dash and C1 dash. Now this is another part of the similar triangle which we have obtained below the body diagonal over here. So this way, all the 8 points of the elevation, they have been appropriately marked over here. And we also know this distance. Please check. Distance between 3 dash and 2 dash 4 dash is known. Distance between C dash and B dash D dash is also known. So distance between C1 dash and B1 dash and D1 dash has been marked. Similarly, the distance between 3,1 dash and 2,1 dash and 4,1 dash has also been marked. So all the 8 points of the elevation, they have been provided to us. Now here we could have provided the angle of inclination of the base with respect to horizontal plane, but we haven't provided the angle of inclination of the base of this cube with respect to the horizontal plane. Rather, we have been provided with this information that this cube is inclined in such a way that this body diagonal happens to be parallel to the horizontal plane. So this way, even now we can evaluate the angle of inclination of the base of this particular cube with respect to the horizontal plane. Now, having evaluated the front view projections of this inclined cube, which has been tilted in such a way that either the base is inclined with respect to HP at a certain angle, or the body diagonal of this particular cube happens to be parallel to the horizontal plane. Now we need to evaluate the top view corresponding projection points corresponding to these 8 points of the elevation. So how that can be done? Now we can see there are 4 points, 1, 2, 3, 4 corresponding to the base. There are 4 points A, B, C, D corresponding to the top face. So corresponding to these 8 points, now we have to look at this particular object or the inclined cube from the top. So the vertical projector lines we have to draw from all of these 8 points into the plan projection view, and wherever these vertical projector lines, they are going to intersect with the corresponding plan projection lines over here, which have been drawn through these 8 points, and these horizontal line intersections, they will be providing us with the corresponding plan projection points which will be available with us in the top view projection. Now let us start with the evaluation of all of these 8 points in the plan projection view corresponding to this inclined cube when the body diagonal happens to be parallel to the horizontal plane. Now we can see these are 2 points, D and 4. We have drawn the horizontal projector line through D and 4. Let us evaluate the intersection of this horizontal projection line drawn through D and 4 with the vertical projector lines which have been drawn through D1 dash and 4-1 dash. So here we can see this is the vertical projector line drawn through D1 dash. It intersects with this horizontal line over here, providing us with the location of the point D1 in the top view projection. Similarly, this is the vertical projector line emerging from 4-1 dash. So wherever it intersects with this horizontal line, we obtain the point 4-1 in the top view projection. Here we have got 4 points which are falling in a same line. So a horizontal projector line we have drawn through these 4 points. Which are these 4 points? A, 1, 3 and C. So now we are going to see wherever these vertical projector lines, they are going to intersect with this horizontal line which is emerging from A, 1, 3 and C. So wherever the intersections of the vertical projectors through A1 dash, 1-1 dash, 3-1 dash and C1 dash will be there with this horizontal projector line. So the 4 points in the top view will be located over here. So please check. This is vertical projector line emerging from 1-1 dash. It intersects with this horizontal line over here, providing us with the location of the point 1-1 in the top view. So this is vertical projector line emerging from A1 dash. So wherever it intersects with this horizontal line, it will provide us with the location of the point A1 in the top view. Similarly, this is point 3-1 dash. So once we draw the vertical projector line through 3-1 dash, wherever it intersects with this horizontal line which has been drawn through the point C, so this point of intersection provides us with the location of the point 3-1 in the top view projection. And here we have point C1 dash. So this is the vertical projector line drawn through C1 dash. It intersects with the horizontal projector line drawn through the point C. We are able to obtain point C1 in the top view projection. And finally, these are the last 2 points, that is 2 and B. So once we draw the horizontal line through the points 2 and B, let us evaluate the intersection of this horizontal line with the vertical projector lines drawn through the points B1 dash and 2-1 dash. So this is our point B1 dash. So from B1 dash, we draw the vertical projector line. Wherever this vertical projector line intersects with this horizontal line drawn through the point B, we obtain the point B1. Wherever we obtain the intersection of this vertical line drawn through the point 2-1 dash with this horizontal line drawn through the point 2, we obtain the point 2-1 over here. So all the 8 points, that is 1-1, 2-1, 3-1, 4-1, A1, B1, C1, D1, they have been obtained. Now which are the edges which we are going to join over here? We are going to join 1-1, 2-1, 3-1, 4-1 and 1-1. We are also going to join A1, B1, C1, D1 and A1. And we are also going to join A1, 1-1, 2-1, B1, 3-1, C1 and D1 and 4-1. But which one of these edges will be drawn using object line? Which one of these edges will be drawn using the hidden line? So we can see that as the observer is going to look at this particular object from the top. Now, point 31 dash, it is the point which is located at the farthest location over here, farthest away from the observer and nearest to the plane. So anything joining 1 point in the top view should be drawn with the help of a hidden line, that is a dotted line, unless that edge happens to fall onto the boundary of the object. So let us join, please check A1, B1, C1, D1, because this is the top face, this is visible to the observer. So everything has been drawn using the object line. Let us now join 1, 1, 2, 1, 3, 1, 4, 1 and 1, 1. Now we can see point 3, 1, it is farthest away from the observer. So 3, 1, 4, 1 has been drawn dotted. 2, 1, 3, 1 also has been drawn dotted. Now let us join A1, 1, 1, 2, 1, B1, 3, 1, C1 and 4, 1, D1. So again 3, 1, C1 will be drawn dotted, whereas another 3 vertical edges, they will be drawn with the help of object lines over here. So this completes the construction of the top view projections of a cube when the cube has been inclined in such a way that the body diagonal of this cube becomes parallel to the horizontal plane. Now in the second iteration, we have been provided with the information that this body diagonal, we can check the top view of this body diagonal happens to be 1, 1, C1. We can check in the front view, this was joined as 1, 1 dash and C1 dash. Whereas in the top view, the body diagonal connecting 1, 1 and C1 will be this one. Now this body diagonal has to be rotated with respect to the vertical plane in such a way that this body diagonal becomes perpendicular to the vertical plane in the second iteration. So now we can see that this top view projection which we have drawn over here, this has been inscribed into a rectangular shape figure over here. So here this rectangular figure which is going to inscribe this top view projection, now this has to be rotated in such a way that 1, 1, C1 should now become perpendicular to the vertical plane. Now you can see here it was parallel to the vertical plane. So now this rectangular shape figure which is going to inscribe this top view projection which we have just obtained, this has to be rotated 90 degree so that 1, 1, C1 should be obtained over here. So this rectangle now we have to transfer at an angle of 90 degree with respect to the vertical plane. And another thing we need to understand, since 1, 1 dash and C1 dash, it happens to be parallel to the horizontal plane. So 1, 1, C1 will be the true length of the body diagonal. So this is also true length of the body diagonal. This is also the true length of the body diagonal. Now using the principle of rectilinear distances, we are going to mark all these 8 points over here such that this body diagonal should become perpendicular to the vertical plane. So this is the rectangular figure which we were talking about earlier. Now this rectangular figure, earlier it was horizontal. It was oriented horizontally. Now this has been rotated vertically over here. So now once we reorient this rectangular figure in the vertical orientation, now we know this distance, it is equal to C1. This distance will give us the point A1 over here. So the midpoint of this and midpoint of this once we obtain, so here we obtain C2, here we obtain 1, 2 point. So this is the midpoint which will give us C2 over here. This is the midpoint of the smaller length of the rectangle which will give us 1, 2. Now we can see this body diagonal now happens to be perpendicular to the vertical plane. Now how do we obtain all the other remaining 6 points? Now please see, we know this edge over here, it is equal to this edge. So from this edge, please check, from this edge, we measure this rectilinear distance, that is distance between C1 and 3,1. So once we measure this distance, again draw another construction line parallel to this edge, we will be able to locate point 3,1 over here. So here from this point, we measure distance C232. This distance will be C232, which is equal to C131. And once we draw this construction line, we are able to obtain the point 32 into this rotated or the translated view. Similarly, from 3,1 we measure this distance. Please check. We measure this distance from 3,1 or we measure this distance from C1. Either way around. Either you measure this distance from C1 or you measure this distance from 3,1. Now another projection line we will be able to obtain, and we will see that onto this projection line on the boundary, points B2 and D2 will be located. So we can see this is point B2, this is point D2 over here. So B2 and D2 points, they have been located at a distance of this much from the C2 or at a distance of this much from 3,2. Once we move to these two endpoints over here, so another couple of points, they have been located into this vertical rectangle. Now again you can see over here, from this point we measure this distance, from this point we measure this distance, and again we draw a perpendicular projector line, and again on the boundary 2, 2 and 4, 2 will be located. You measure this distance, move to the boundary, so this distance will give me 2, 2, this distance will give me 4, 2. Again you can check, this distance we will measure equal to this distance. So this distance, it is equal to this distance. Let me draw. And now once you go to boundary, so 2, 2 and 4, 2 will be located. And next, here we have this point which is equal to this point. From this point you measure this distance. And the moment you measure this distance, point A1 will be located. And here point A2 will be located. So same way, you measure this distance and draw a construction line, point A2 will be located. So all the 8 points which were located in the plan projection view while the body diagonal was parallel to the vertical plane, now they have been transferred into a position when the body diagonal happens to be perpendicular to the vertical plane. So this plan projection view, it has been rotated 90 degree to the vertical plane using the principle of rectilinear distances transfer over here. So having obtained these 8 points, so whichever points they were joined over here using object line, same points will be joined over here using object line. Whichever points were available over here using hidden line or the dotted line, same points they have been joined using hidden line or the dotted line over here. So this is the transformation of the plan projection view by 90 degree. So this has been obtained in the oblique construction of this cube. So this is an oblique cube in which the body diagonal happens to be horizontal to the horizontal plane and it happens to be perpendicular to the vertical plane over here. So this way, this is the construction of the orthographic top view projections of a cube which is oblique in nature, that is inclined to HP and inclined to VP. Inclined to HP at this angle, inclined to VP at an angle of 90 degree. Now, having obtained the top view projections of this cube, now we are required to obtain the front view orthographic projections of this oblique cube over here. So in the 6th iteration, we are required to draw the corresponding point. Now how many points were there? 8 points we have already located in the top view projections. Now these 8 points we are going to locate in the front view projections. How we can do that? From these 8 points in the top view construction over here, now we are going to draw the vertical projectors through these 8 points. Now we are going to draw the horizontal projector lines from the previous elevation projection view. So wherever the intersection of the corresponding points will be obtained over here, So we will be able to locate all the 8 points corresponding to this oblique cube in the front view projections over here. So let us proceed with the identification and location of all these 8 points corresponding to this oblique solid. So the first point which is available with us, it is over here, A1 dash. So let us draw the horizontal projector through A1 dash. So wherever this horizontal projector through A1 dash, it is going to intersect with vertical projector through the point A2. We will be obtaining the point A2 dash over here. Now the next point which is available with us, it is B1 dash and D1 dash. So now through B1 dash and D1 dash, we have drawn a horizontal projector line. So wherever this horizontal projector line, it intersects with the vertical projector lines which are emerging through the points B2 and D2 from the top view, we are going to obtain the points B2 dash and D2 dash in the top view. So please check, this is point B2. From B2, we have drawn this vertical projector line. It intersects with this horizontal line over here. So we obtain the point B2 dash over here. Similarly, this is the point D2 over here. So from D2, we have drawn a vertical projector line. Wherever this vertical projector line through D2, it intersects with the horizontal projector line drawn through D1 dash, we have obtained the point D2 dash over here. Now the next 2 points we have got 1 dash and C1 dash. They are again falling in one line. So from 1 dash and C1 dash, again another horizontal projector line has been drawn. So wherever this horizontal projector line, it intersects with the vertical projector line drawn through 1, 2 and C2 over here. This is 1, 2, this is C2. So again this is overlapping. 1, 2 and C2, they are overlapping. So horizontal line 1 dash and C1 dash is overlapping. The vertical projector line 1, 2 and C2 is overlapping. So here one point will be available, that is a common point is available, which will locate the points 1, 2 dash and C2 dash over here. Now next point which is available with us, it is 2, 1 dash and 4, 1 dash. So from 2, 1 dash and 4, 1 dash, we have drawn a horizontal projector line. So wherever this horizontal projector line, it intersects with the vertical projectors which are emerging from the points 2, 2 and 4, 2. So another 2 points we are going to obtain in the front view projection. So here we can see this is vertical projector line emerging from 2, 2. It intersects with the horizontal projector line emerging from 2, 1 dash. So here we obtain the point 2, 2 dash. Similarly, this is vertical projector line from 4, 2. So vertical projector line from 4, 2 intersecting with horizontal projector line from 4, 1 dash. So this intersection point provides us with the location of the point 4, 2 dash over here. And finally the last point is 3, 1 dash. So from 3, 1 dash, we are going to draw a horizontal projector line. From point 3, this is point 3, 2. So from point 3, 2, we draw the vertical projector line. So the point of intersection is this one. So here we obtain the point 3, 2 dash. So we can check all the 8 points of the front view projection corresponding to this oblique cube. They have been obtained. Now which are the points which we have to join? 1, 2 dash, 2, 2 dash, 3, 2 dash, 4, 2 dash and 1, 2 dash. Similarly, A2 dash, B2 dash, C2 dash, D2 dash and A2 dash. And finally, 1, 2 dash and A2 dash has to be joined. B2 dash and 2, 2 dash has to be joined. 3, 2 dash and C2 dash has to be joined. D2 dash and 4, 2 dash also has to be joined. But which one of these edges they have to be joined dark? Which one of these edges they have to be joined using the hidden line? Now we can see as the observer is going to look at the solid from this position, point number C2, it happens to be located farthest away from the observer. So anything joining C2 dash in the front view has to be drawn dotted unless it appears onto the boundary of the solid. Now let us join the different points. Now we can see, since we are going to look at the solid from this side, so we are going to join 1 2 dash, 2 2 dash, 3 2 dash and 4 2 dash using the object line. Similarly, let us join A2 dash, B2 dash and then B2 dash, C2 dash, because anything joining C2 dash has to be joined with hidden line. So this is the hidden line which we have drawn because it is not falling onto the boundary. Similarly, C2 dash, D2 dash has to be joined again dotted because it is not falling in the boundary. And once we join all the other edges, so C2 dash and 3 2 dash has to be joined again dotted because we can see it is falling on the back side. It is falling onto the back side. So this way we have to join everything else using the object line, only 3 edges, that is C2 dash, D2 dash, C2 dash, B2 dash, C2 dash, 3 2 dash. So these 3 edges, they will be joined with the help of hidden line or the dotted line. So this way we can see that we have been able to obtain the orthographic front view projections, the orthographic top view projections of an oblique cube in which the body diagonal happens to be parallel to the horizontal plane and the same body diagonal 1 to C, it means 1 2 and C2, it happens to be perpendicular to the vertical plane. So corresponding to this oblique solid or the oblique cube, we have been able to evaluate the front view projections as well as the top view projections of this particular oblique cube. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic front view and the top view projections of an oblique solid when the orientation of the solid with respect to the horizontal plane as well as the vertical plane have been provided to us. So we will be continuing with further discussion regarding few more illustrative cases of projections of the solids in the coming lectures. So thank you very much. Thanks a lot.